All right, we have two more limit laws that we want to take a look at. The first one, which I'm going to put as number 10, since we finished with number 9 in the last video. The limit as x approaches a of the nth root of x is equal to the nth root of a. So this is kind of similar to the one that we looked at earlier, where we looked at the limit of x to the nth power, but now we're looking at the nth root. And remember, a root is just a fractional power. So this rule of looking at a power of x will also extend to looking at a root of x. And of course, if n is an even number, if we're looking at an even root, then of course we need a to be positive. It doesn't work if we're taking an even root of a negative number. Of course, that would give us imaginary numbers. That doesn't quite make sense. So we assume in that case that a is greater than 0. And we've got one more related rule here. And this one says if we're taking the limit of the nth root of a function as x approaches a, we can take that whole limit and bring it inside the root, and we can evaluate the limit of the function first and then take the nth root of that. Again, where n is a positive integer. And again, if n is even, we're assuming that what we've got on the inside is greater than 0. So these rules are useful in line with the direct substitution property. Let me show you an example. Let's evaluate the limit as x approaches 2 of the square root of 2x squared plus 1 over 3x minus 2. Now, we can't use the direct substitution property right away because this is not a polynomial or rational function that we're taking the limit of, but we can use rule number 11 to take that limit and move it inside the radical. So this becomes the square root of the limit as x approaches 2 of 2x squared plus 1 all over 3x minus 2. And now that we've used that rule, if we look inside the square root, we have the limit of a rational function, and we can use the direct substitution property so long as it doesn't give us a 0 in the denominator. So that's going to give us 2 times 2 squared plus 1 all over 3 times 2 minus 2. And when we evaluate that, the numerator is going to become 9, and the denominator is going to become 4. And the square root of 9/4 is 3/2. So this expands what we're able to evaluate by direct substitution by allowing us to do that when we have the limit of a square root or a cube root or a fourth root or something like that. Now, I want to look at one more limit really quick before we finish. Let's evaluate the limit as x approaches 0 of cosine of x minus 1 all over x. Now, this is a limit where we cannot use any of the rules, any of the laws that we've seen today, because none of this involves polynomial functions or radicals. We've got this cosine of x in here, and so none of those laws work. And I just wanted to look at this to remind you that if these laws that we're learning don't apply, it doesn't mean the limit doesn't exist. We just need to use other tools, and one of those tools is a table of values. And to not waste time, I'm just going to give you the table of values. All of these are from plugging into a calculator. And we can see here, as x approaches 0 from the right-hand side, from the positive direction, we have our values that are also approaching 0, though from the negative direction. Doesn't matter, they're approaching 0. And then from the left-hand side, as our x values approach 0, the function values also approach 0, so that tells us that the limit looks like it is equal to 0. So Just because the rules that we've learned, the limit laws that we've learned, don't apply in certain situations, it doesn't mean that a limit doesn't necessarily exist. It just means that we have to look at other tools.